This video is on kinetics. And our aims for this video are to define activation energy, define catalyst and explain how catalysts work, which are two different things, draw Maxwell-Boltzmann curves for different conditions, and explain the effect of temperature on reaction rate. So first, our definition of activation energy has to be very precise when you're in the exam, and the first point you have to, or first word you've got to use is the word minimum. And if you don't use that word, then you won't get both marks. So it's the minimum amount of energy required between two particles for them to react. So you've got to remember that it's the minimum amount of energy, and that's the amount of energy required for a reaction to happen, basically. So another definition here is catalysts. So remember, a catalyst is just something that is added to a reaction that speeds it up but doesn't get used up itself. So that's the definition. So a catalyst is a substance that speeds up a reaction but does not get used up. Now it's important that this word up is used, and I'll explain why. So if you just said a substance that speeds up a reaction but does not get used, that is incorrect, because the catalyst does get used, it's just it gets remade again at the end. So you've got to say it doesn't get used up, because that word up basically makes this definition imply that it does get made again. So you've got to remember that you've got to use the expression used up, not just used. So a substance that speeds up a reaction but does not get used up. You could say a substance speeds up a reaction but is not chemically changed at the end. So that would be okay as well, but I would stick to this definition if I was you. And then how it works is, again, a specific explanation is needed, and that is that the catalyst provides an alternative route. That's your first mark. That has a lower activation energy, and that's your second mark. So if a question says how does a catalyst work, you'll go for this second one. If a question says what is a catalyst, you'll go for this first one. And there'll be very subtly different questions in the exam, so you've got to make sure you pick the right answer when you get to your exam. So next aim, draw Maxwell-Boltzmann curves for different conditions. So first let's explain what a Maxwell-Boltzmann curve is. Basically, a Maxwell-Boltzmann curve is a graph that shows you the distribution of energies that molecules have at different temperatures. So you have two axes. The bottom axis is energy. This axis here can either be proportional of molecules or number of molecules. I'm going to go for number of molecules. That's what I've seen most in exam. And at just a random temperature, you can give this a distribution of this. So you can see, and you can also mark the activation energy. So here would be the activation energy. So basically all of these molecules have the required energy in order to react at this temperature. There's a couple of points on here. Firstly, you've got the most probable energy and the average energy, or the mean energy. Now the most probable energy is here. It's the peak. So most probable energy. So that is the peak of the graph. But the average energy is actually shifted slightly to the right, because most molecules are on this side of the peak rather than this side of the peak. So if you wanted the average energy, that would be around here. Now, what an exam would probably ask you to do is draw the distribution at colder and and hotter temperatures. So if we start with a hotter temperature, so I'm going to use a different colour now, let's go for orange. So a hotter temperature, you've got to think about what happens to this peak and what happens to the number of molecules above the activation energy. The number of molecules above the activation energy is going to be higher, and the peak therefore is going to shift to the right and be lower. And I see a lot of students, when they draw this, they draw it so that it's only slightly further to the right and is only slightly lower. And I'd rather you didn't take the risk in the exam and draw it like that, because you would probably get both marks if you drew it like that, because it is slightly lower than the peak and it is further to right, but make it obvious for the examiner. So instead, I would prefer you to... Oh, it doesn't look like I can rub this out now. Bear with me a second. Instead, if I just rub this out, I would prefer you to draw it more obviously. And when I say that, I mean do it like this. So you can see that peak is obviously further to the right and obviously is lower down. And you can also see that there are more molecules with an activation energy higher than an energy higher than the activation energy. Don't let this line touch this line. Make sure it's always above it, apart from near the beginning. Now, if you're doing it colder, then that would mean the peak would be higher and further to the left, and your number of molecules with energy higher than the activation energy would be lower. So this peak would represent a temperature which is lower than this temperature here. If you're using a catalyst, then the activation energy moves rather than the distribution of molecules, and so with a catalyst your activation energy would move further to the left. And so that would mean that, again, more molecules have the energy required to react, or the minimum energy required to react. So we can use that Maxwell-Boltzmann distribution to explain the effect of temperature on the reaction rate. And if they ask you why increasing the temperature increases the reaction rate, they only really want one thing, and that is that there are more molecules that have the required energy to react, or have an energy higher than the activation energy. That'll get you 1 mark. The other word they want to get 2 marks is many. So many more molecules have an energy greater than the activation energy. And that will get you 2 marks for explaining why increasing the temperature increases the reaction rate. Conversely, if they ask you why a lower temperature decreases the reaction rate, you'd say that many fewer molecules have an energy lower than the activation energy, or many fewer molecules, sorry, have an energy greater than the activation energy, basically. It would be the converse of this argument anyway. So let's have a look at a few past exam questions. So this first one, the diagram below shows the Maxwell-Boltzmann distribution for a sample of gas at a fixed temperature. EA is the activation energy, there it is. On this diagram, sketch the distribution for the same sample of gas at a higher temperature. So remember, don't take any chances, exaggerate your curve, and so we're going to make sure our peak is further to the right and lower down. There's our peak, and make sure that your line stays above the line above the activation energy. So that'll get you 2 marks. And it says, with reference to the Maxwell-Boltzmann distribution, explain why an increase in temperature decreases the rate of a chemical reaction. Notice how many marks there are for this. Can you see it? Oh no, you can't. I've cut it off. But there are 2 marks for this, and that's because they want the word many first. That'll give you your first mark. If you have everything else, that won't get you any marks, just writing many by itself. So many more molecules have an energy greater than the EA. You don't have to write activation energy, you can just use the symbol, seeing as they've done that in the graph. So this is a slightly different question on Maxwell-Boltzmann distribution. It gives you a distribution and asks you how these 2 values change if you change the conditions. And to answer this question, you've really got to just think about how the curve changes, because the most probable energy, the EMP, they've called this on the graph, will only change if the position of the peak changes in the graph. Similarly, the EA will only change if, well, the position of the EA changes on the graph, which can only be done with a catalyst. So you've just got to think about what will happen to the curve if you change the conditions. The first question says, state how, if at all, the value of the most probable energy, i.e. the peak, changes the total number of molecules and increase at a constant temperature. So at a constant temperature, and with more molecules, all this graph will do is just follow the same line, but just be a little bit taller, because there's more molecules in this experiment. And so if all it happens is it gets taller, the peak will stay in the same position. So that means there's no change in the most probable energy. Second question says, state how, if at all, the number of molecules with most probable energy change the temperature is decreased. So this time again, just going to draw on the curve, and you'll notice that the peak goes to the left and a bit higher, because at a colder temperature, that's what happens. The peak moves to the left. So that means the most probable energy has decreased. It's gone to the left and therefore has decreased. So the EMP decreases. Then, next question, state how, if at all, the number of molecules of energy greater than the activation energy changes as the temperature is increased without changing the total number of molecules. So again, just draw what will happen to the graph on the graph. So draw the new curve. The temperature is increased, so it moves further to the left, and the line gets higher than the activation energy. So here, the number of molecules of energy greater than the activation energy will increase. There's many more molecules there, and so you can write that in. And then finally, state how, if at all, the area under the molecular energy distribution curve changes as a catalyst is introduced. Now, all a catalyst does is it moves the activation energy. It does nothing to the distribution. And so again, this will be no change. If this question was state how catalyst affects the number of molecules with activation energy, or energy higher than the activation energy, that would be increased, because if the activation energy is moved down, that increases the number of molecules on the right of the activation energy. A couple of definitions now here. So, give the meaning of the term activation energy. Remember, we need the word minimum in first. That's a key word required for both marks. So, minimum amount of energy a particle must have to react. That'll get you 2 marks. And then explain how a catalyst increases the rate of reaction. So here it's not asking for the definition of a catalyst, not saying what it is, it's saying how it works. Explain how a catalyst increases the rate of reaction. So first step is it gives an alternative route, and the second mark is for it gives an alternative route with a lower activation energy. And probably want to add here, gives an alternative route for reaction to occur. Don't let the examiner assume anything.